we have studied this some of the like pulse generator, RAM, constant clock, and repeating sequence. Now we are studying at repeating sequence stairs. Okay, so discrete time sequence is output. Okay, then repeated. It's repeated various times after this and all. Okay, so from here also I can change the sequence what I want. So if I want the sequence 0, 1, 0, 1, or like 1, 1, 1, 1, 0 in that way. Suppose if I want some one sequence, okay, fine. So this is a scope. As I showed you how we can change a property of this display. Here we can change a property of scopes as well. Okay. So in view, if I'm coming to the layout, if I'm taking the two like various layout, how many graphs we can see in one scope, that thing also possible here. Okay, and we can adjust, we can zoom, there are various settings also, we can take a print of all and all these things, zoom x-axis, zoom y-axis, and all these things. Suppose if I want these here, if I'm coming, I'm getting a layout, but in the setting, if I'm coming here I have number of inputs. If I'm making it 2 and apply it, and okay, so you can see now there is one more port is created. And in that I'm connecting the same whatever the input is here, that same input only we are seeing, that multiple ports should be connected. Okay, multiple ports should be connected here. So that thing we can take multiple displays in the scope, not only 2, 3, 4, 5. We can take how much we want. Okay, so you can see here whatever sequence I have given, 0, 1, 0, 1, 1, 0, 0, 1, 0. In that way that sequence is going. Suppose I am changing the sequence to the only 0, 1, 0. No, 0, 1, 0, 1, 0, 1, 0. In that way, it will then. Okay. At last, it will come like 2 zeros according to this, but and then apply it, it will work now in a simple way. But you can see now that sequence come 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1. You can see the partition is divided like here, that first step like 0, 1, 0, 1, 0, 0, 1, 0, 1, and that way that graph is divided. Okay, so that how in that way we can give a repeating sequence what we want. Now this is a sine wave. If this sine wave, okay, not only the sine wave, I can change the various properties with this. I have, if I is required for a time based or it's required for a sample based. Time based where we can use, and sample based where we can use. Time based is used for variable time variables as a type of solver, and sample based is used when we have a fixed type of a solver. This is a sine wave. Okay, and we can if we want, we can get various input waves from here. You can see not only sine. If I want, suppose cos, so I'll get it here from cosine wave. Cos, Simulink cos, this is cos theta. There is various trigonometric function also I will get. And suppose if I want to change this property, there we can change various ways. That property as well, sine wave, cosine wave, how we can change the issue. So here you can see in this graph, we have sine wave 0 to 1, again 1 to 0, again 0 to -1, -1 to 0, 1 in that way. Okay, this is a sine, and this is a step. Where we can use step, and what is the step? For enabling anything, we require a step. Enabling anything means, suppose if we have some conditionally executed subsystem and we learn that, we will get the better idea. Suppose if I want to enable something logic, in that way, how enable? As you can think about it, we have a key ignition project. In that, my key is detected. My key is present there. That is my enabling signal for that project. That is my enabling signal for that project. Once it will key is detected, that only that rest of the 3, 4, whatever ignition on accessories, that position should be happen. So you can see here in a step, I have given step is 1. In that way, it will be in a graph, it should be present. It will be started from 0 at 1, it came again, it become a 1 and it is going continuously. Okay, this is a step. So these are the few examples of source and sink library which we can use.